Let me start by thanking Roxana Dumitrache and all the team at the Romanian Cultural Institute in London for their invitation to present here a few ideas related to the Romanian tradition in mathematics. Something that's sometimes well known, sometimes forgotten, but nevertheless, it's a very valuable experience, very important today, especially today. So let me start by mentioning that the title of this presentation is related to the Mathematical Gazette, a monthly published in Bucharest since 1895. How from this tradition the International Olympiad, the Mathematical Olympiads were born is the story I'm going to tell today. Well, today sometimes we're talking about the pleasure of test taking. I mean, really? How does it look? Well, is there such a thing? Here's an image with my students taking with great pleasure the Putnam competition at Cal State Fullerton. I wish I was young enough to take it, as I took Olympiads many years ago. Nevertheless, these ideas, these pieces of information are reaching the mainstream media from time to time, usually in the summer, when the International Math Olympiads are taking place. They are a matter of national pride and reflection in many cultures. Here's an image with Potion Low describing his approach in training Team USA. There was at the joint mathematical meetings in Denver, Colorado, when I had the honor of organizing a special session focused on training of highly gifted students. That's one of the ideas we're interested in. Now, while non-mathematical audiences often focus on the performance of, let's say, Team USA or the local team, this prestigious event serves as an opportunity to think about what are we actually interested in the education process. To cite one example related to Team USA, Potion wrote that math is not about memorizing formulae without meaning, but rather about learning how to reason logically through precise statements. Now, go ahead and tell that to large audiences. This is something that must be reminded from time to time. It's important. Now, in the United States in particular, the process of selecting the team goes through different stages, which are the North American Olympiads. First, the AMCs, then the American Invitational Math Examination, also called AMY, the USA Math Olympiads, and then they have other two tests after the training sessions that are taking place usually in the summer. This is how the top 6 are chosen. Now, what is this? This is like in the Olympics when we run track and field and we choose top 6, or it's what? This has to do with a very important intellectual idea, whose roots can be traced back to the last decades of the 19th century. It's important to know. On the other hand, in terms of structure, the International Math Olympiads can be traced back to the Romania in the 50s. And that idea was rooted in the tradition I mentioned. In the United States, the William Lowell Putnam competition was established in 1937 as a college-level event. Now, this is important because there are different traditions in various mathematical schools, like, for example, the Eötvös tradition in Hungary, or the traditions I mentioned before. When they merged together into an international event, the idea becomes clear. And this is what it matters. The initiative to organize the International Math Olympiads fell to the Romanian Society for Mathematical and Physical Sciences, as it was called at that time. In that historical period, the president of the society was Grigore Moisil, and the vice presidents were Caius Iacob and Nicolae Teodorescu. Grigore Moisil served as the president of the society until 1973, and Nicolae Teodorescu took over thereafter. Their generation, for all of them, had a certain model in mind, the old contest of the Mathematical Gazette, and that was useful and inspiring. they believe in it. They believe that maybe that gathering of intelligent people, intelligent young people, that serves a purpose, a noble goal. As for the Gazette, it was there since forever. This is a copy of a Gazette I owned since, maybe back in the 80s. And the Gazette is 125 years young at this time. At the beginning of the 90s, the printing format reduced a little bit, still the same valuable resource, looking more shiny nowadays. What's important is that we actually have more than a century of a whole database of problems, something that we call age-appropriate problems, because it's not about asking very tough questions that children can do. It's about asking those questions that are interesting, inspiring, that turn young minds into potential future scholars. That is the catch. Now, the first decades of the Gazette are related to the name of Gheorghe Țițeica, who was an orphan, and he managed, due to his amazing qualities, to support himself in school by scholarship his whole life. He graduated with from math in Bucharest in 1896, then moved over in Paris, pursuing 1 year of école préparatoire. By the way, he was a friend at the time and colleague with Henri Lebesgue in that particular academic year. In July 1897, we know he passed certifying exams in differential and integral calculus, then in mechanics, and then in astronomy. He ranked first in his cohort when he obtained a second undergrad degree from the Sorbonne. This entitled him to a full tuition waiver, and this is what helped a lot in him paying the bills in Paris and being able to complete his studies. He had the chance to work with the best mathematical minds in that historical period, in that time. It was a glorious moment for École Normale Supérieure. And in the end, Țițeica wrote his thesis under Gaston Darboux supervision. In a time when Gaston Darboux actually was serving as a dean. He defended his doctoral thesis at 23 years old, then returned to Bucharest. He wrote a lot, both in terms of research and in terms of education. Well, for the education, he served as a member of the editorial board of the Gazette, and he was very active until 1937. His last 2 years, unfortunately for medical reasons, he wasn't as much involved, but for more than 3 decades, he was the heart and the soul of the Gazette. Now, the Gazette contest was consistent in 2 written texts and 1 oral examination. Țițeica was writing an editorial praising the qualities of the winners, and he was fair, particularly fair in pointing out strengths and in the same time mentioning weaknesses. The first story I'd like to mention is that of Sebastian Kaufmann, who was originally from Moldova. He was criticized originally for not mastering well trigonometry. Now, whatever happened there, that criticism was motivating. And in a couple of years, Kaufmann becomes an expert in matters of trigonometry, and he's writing this particular paper called On Some Algebraic Curves, where he's asking a question about the power of a point with respect to an algebraic curve in the plane, and he's using masterfully trigonometry to investigate the question. Now, if we're looking carefully what happened with that idea, we find the same thought in a paper published in London after World War II in the Mathematical Gazette based in UK. And then there is another very interesting paper sur la puissance d'un point par rapport à un conique, where the same idea is investigated. So this high school student from Romania is actually anticipating an idea, very fundamental idea, that was later on picked up by other researchers. Very interesting story. So whatever Țițeica did, that little bit of suggestion, criticism helped, in the sense that Kaufmann managed to produce an accomplished idea. The second story I'd like to mention is that of Dan Barberian, who was a winner of the Gazette contest in in 1912. Today his name is mentioned in the mathematical subject classification. It's perhaps one of the highest honors a mathematician can ever dream of. This is reserved for founders of research field. So Barbenian is associated specifically with 51C05. Okay. Very valuable. He introduced in 1934 the so-called Apollonian metrics. He called them so. Today we refer to them also as Barbenian spaces. Very creative mind, and we're going to get a chance to talk more about him in a few minutes. We can cite a plethora of examples of creative minds educated with the old Gazette. Now, in this sense, the Gazette contest worked. It motivated young minds to pursue their talent and express themselves through mathematics. Let's try to clarify this idea. When do we say that a program actually works? When it is inspiring, when it creates a motivating atmosphere, when young people are joining the program with pleasure, and when they think about these problems, when their whole heart and mind is in it. Here's what we do at Cal State Fullerton. Here's Orange County Register reporting on our Fullerton Math Circle, an outreach program of the Department of Math. So we've been doing that for over a decade, and basically the trick is to translate the problems from the Romanian Gazette and invite our students to work on them, to think about them, to reflect on these problems, and their projects are becoming posters, are becoming a matter of discussion and presentations, and this is it. We're replicating the Bucharest model, and it works. Beautiful problems trigger imagination. Back to the story. In 1956, took place the Congress of Romanian Mathematicians. Several mathematicians from various nations have been approached to see whether there is an interest for an international event dedicated to math problem solving. We have a couple of pictures. This is from the Barbenian archive. It was published in a volume dedicated to Barbenian's writing. Barbenian is right here. It's a few years before he passed away. And quite interestingly, we see here Barbenian with Wilhelm Blaschke. Very important, because in 1921, actually, Țițeica suggested Barbenian to write his doctoral thesis with Blaschke, an advice that Barbenian didn't follow. Also with Ben is Professor de Joie, and we'll see the connection right away. In Barbenian's archive, there are a few notes from the 1950s, when an old Barbenian goes back to the problem in the Gazette. Problems from La Belle Époque from 1912, 1913, where he's reflecting from an advanced viewpoint to some elementary phenomena he saw published in that decade. It's very interesting that an accomplished mathematician would do that. In another place, he is remarking, "This is my figure, I recognize it," and he's with great pride looking back to the decades past, and he finds this feeling of accomplishment and tries to generalize ideas. In a couple of the notes here, he completed in the later years in his life are quite interesting, quite interesting. One of the central figures who played an important part in establishing the IMO was Nicolae Teodorescu. Born in 1908, received his high school education at the elite high school named after Spiru Haret. Doctoral thesis defended in 1931 at the same Faculté des Sciences de Paris, under the coordination of Henri Villa, with a committee including Arnaud Dejoie, we have seen him a couple of slides ago in a picture, and Henri Baguin. And that's the cover of the thesis. It was an absolutely marvelous accomplishment for somebody so young. He was 22, 23 when he obtained these results. And we're looking at this absolutely brilliant accomplishment with great admiration today. his career, he taught mainly partial differential equations in Bucharest, then became a member of the Romanian Academy in 1963 and served as a dean of mathematics for many years. And while he did all of that, he was, like Țițeica, very much interested in education. He coordinated the components of the Romanian Math Olympiads, part of his work as a president of the Romanian Mathematical Society. In 1956, that Congress was the perfect opportunity to approach various mathematicians from different cultures about the idea of possible international event involving high school students. It worked. The first International Math Olympiad took place in 1959 in Brașov. Several nations taking part. 7 was Bulgaria, Czechoslovakia, East Germany, Hungary, Poland, Romania, and USSR. Since USSR ranked 6th, the country decided not to participate in the 1960 and 1961 editions. First time when a Western nation joined was in 1965, and it was Finland. First UK participation in 1967, and actually the United Kingdom hosted the events 3 times, most recently in 2019 in Bath. The impact of the phenomenon is wide. 112 nations participating in the 2019 edition. Now, here's a picture with Nicolae Teodorescu from his later years, from the 80s. One of the scholars he approached in 1956 was actually Jacques Hadamard, this amazing geometer and analyst who was very much interested in the psychology of mathematical creativity. He wrote actually in the 40s an important essay about this theme, and I know for sure that there were a lot of conversations about this idea between Nicolae Teodorescu and Jacques Hadamard. And the main question was, why in the world do we do this? How can we help young minds become more creative? How can we inspire them? That is the point. So this is a question that permeates this whole conversation. This is not about competition. This is not track and field. It's about something higher. We have here another image from a lecture that Nicolae Teodorescu was giving in the 80s. He was active until his last years. He still writing reports on doctoral thesis, here still refereeing, very active. However, if it's about Olympiads, Nicolae Teodorescu had one major concern. Does the evolution of the event change problem solving into a race as opposed to the thorough and deliberate investigation that mathematical research is supposed to require? So in order to provide high school students with an experience closer to what he envisioned, Nicolae Teodorescu worked to revive the old context of the Mathematical Gazette. So he went back in the 80s to try to recreate that context that Țițeica had in the first part of the 20th century. Every issue of the Mathematical Gazette included a section called Proposed Problem for the Annual Contest, which usually included 3 problems per issue. They were harder, about the level of the problems published every month by the American Mathematical Monthly. So they were keeping track of the points, and the top problem solvers were invited in a sort of summer school / competition that was taking place in end of July, August. The first part of the summer school was dedicated to invited addresses and lectures, and the actual competition was occurring at the end. This is something that's very similar to programs developed in various mathematical cultures today. We call them research experience for undergraduates. Very, very similar as idea. Now the competition was made up of 2 tests, each with 3 problems and 4 hours to work on them. So that's like the old contest. There was no oral examination, no more. It was too stressful. Perhaps it was better. Interestingly, Nicolae Teodorescu designed the two parts to assess different skills. And the two tests were titled Mathematical Reasoning and Mathematical Technique. I mean, this is entirely different. For one test, the students were invited to think about the structure of a proof. And in the second test, the paradigm was different. It was like calculate in an intelligent way. This was his vision. So let's see, how were these ideas different? Let me go back to the archive and take a look at what happened in 1987. So this is the contest that we can see here. The problems are not really geared towards let's calculate. It's more like let's think in a very effective way. Let's elaborate in terms of reasoning. It's more about logic blended with mathematics than about blind computations. On the other hand, if we're looking at the mathematical technique examination, the problems have a completely different spirit. Here, one has to calculate very well and very effectively. And even if the time is, you have plenty of time during the competition, the problems are challenging. So there's a key distinction to be made between these two classes of problems. They represent the two essential sides of mathematics. That means, by one hand, the spirit of applied mathematics, of trying to calculate, to perform numerical approaches. And the other one, the spirit of pure mathematics, where logic and reflections on the foundations of the problem is extremely important. For Nicolae Teodorescu, it was clear, and he converted into an institutional experience this distinction between the two branches of contemporary mathematics. Aside from their insightful and inspiring structure, the annual examinations designed by Nicolae Teodorescu carried one more important consideration: Catch-22. The contestants were actively encouraged to think of and develop extensions and generalizations to the problems assigned in the competitions. Submissions of such contributions were awarded with bonus points. So, if you are 15 or if you are 17 and if you are told you're going to get 5 bonus points if you come up with a generalization, you're going to love this idea. As a consequence, high school students were invited to experience the work of an actual research mathematician and ask themselves whether a more general principle could be drawn from each individual statement. So, problems with a more generalizable underlying concept will stand better chances to be selected for the examination. And the problem writers were thinking the whole year long to such problems. Now, sometimes this particular aspect will become the central focus of the problem writing process. That is, the potential for a problem to lead into a more extensive and fundamental investigation into mathematics. That's exactly what Barbinian was actually doing. When you are going back to a problem that you solved 40 years ago, to think about, to reflect, to try to extend it, that's the spirit, that's the tradition. That's what we actually try to achieve. And this is not about competition between nations. It's not about competition between individuals. It's not about that. It's about that spark of inspiration for young minds to create, to express themselves. On this point, the format of the contest in those years, in the 80s, was very different from that of the mathematical Olympiads, which existed on a different academic calendar and culminated with the IMO in the month of July. Designed to be enjoyed, oh, this word, on a more relaxed timescale, with a competition taking place in August. The Gazette's contest invited in spirit through carefully crafted one-of-a-kind problems. an experience that was essentially age-appropriate research work. The important takeaway from this story is that while some mathematical competitions are problem-solving experiences for K-12 students, one must ask whether or not such intellectual environments motivate, inspire, and spark mathematical creativity. In the actual mathematical Olympiads around the world, students are fundamentally expected to solve problems. Some of these problems are extremely difficult, and sometimes in the IMO, students are presented with problems of particular difficulty. This aspect is very similar to mathematical research in spirit. However, we must ask if there is anything missing from the whole problem-solving experience. The real undertaking is whether the training for elementary math competitions actually ushers in the students' minds the desire to extend, generalize, pursue an idea, explore by themselves, and express themselves through mathematics. For any professional mathematician, finding the right question to work on represents one of the central features of the mathematical craft. This question is presented to every generation of mathematicians, both in terms of problem writing, which is never a trivial task, and in terms of finding pleasant and motivating ways to train young, interested minds. How to accomplish such a task is a very complex challenge and important for any educator interested in the training of their most creative students. Perhaps some accounts from our mathematical past will inspire further reflection and discussion, as many mathematical cultures have already explored and made valuable progress in this perennial collaborative effort. Thank you.